You thought you knew how to count. Well, that's what we're going to be doing for the next month or so, is counting things. It seems easy, but it's going to get quite advanced. And it's going to be quite useful in some word problem application in business and school and all kinds of things. Okay? But the way we're going to do these advanced ones is we're going to use this tool that we did last time. Do you remember from last time? We learned about Venn diagrams.
How about little fires, Scarecrow?
Let's do a couple of problems that we did last time. And hopefully I can involve all the concepts that we did last time. See if you remember this one. We're supposed to come up with a picture of A unioned with B complement intersected with C and then subtract B. Whew. Well, oh yeah, I had that check mark and shade method and multiple picture method. Okay, so I'm going to start with the innermost parentheses and use the check mark method to do A unioned with B. That's what that U stands for, unioned with B. And that's everything that's in A or in B. You don't have to be in both. Okay, that's everything that's in A. Now let's add everything that's in B, but the things that are in A I don't want to do twice. Okay, there we go. That's A unioned with B. Now let's see. That's A unioned with B. I've got to get the rest of this.
All in good time, my little pretty. All in good time.
Okay, well, you know what? I'm not going to get lazy here. Let me do another picture to do this portion. I want to do the complement of that, which means everything in the universe, which is the square box, everything in the universe except what I've check marked. I hope you appreciate that's everything except the check marks. Okay? Now, I'm going to intersect that portion with C. In other words, what portion is yellow and is also in C? Right there, isn't it? Okay? So I'm guessing that's my answer so far. I got one...
Not because they are easy, but because they are
one
hard.
little bit thing, and I'm supposed to subtract any portion of B from that. And I could do that.
Hey, wait just a minute.
But in this case, there is no portion of B in it. And that's a little trick. That could happen. Okay, so...
You've absolutely proved to yourself and to the audience that you deserve to
So
be
we
in this
did it.
competition.
Okay? It's not too bad. We do a little bit at a time. Note that we use the check marks and multiple pictures. Okay? Let's do maybe one more. Look at this one. Whew. Well, remember, we always do what's in parentheses first. And I guess we do the leftmost parentheses. So everything that's in A, but take away any portion there of C. There you go. Anything that's in A, and C took a bite out of it, if you would.
Whoa!
Okay, now this one, I'm gonna do this in a separate picture. C complement, everything but C. And I want to intersect that with B. Intersect that with B. What portion of this is also in B? See the check marks. Okay, so that's B intersected with C complement. There it is. I want to union these two together.
Now what am I gonna do?
Remember when you union, basically you just shade everything that's in both. So I'm looking at, that's the first picture. And the second picture is this, and I think that's it.
Woohoo! Come to Papa.
Okay, that's about all we covered last time. That's a lot. Okay, now how are we going to use that to count, and why would we need it to count?
Excuse me, Professor Brainiac.
There's another thing that we're going to use, I forgot to tell you. And that's going to be an identity. Okay, now an identity, no matter what you're in, if you're in math or whatever field, is going to be something that you can use and know that it's always going to be true, independent of whatever set you use. Okay? I'll give you an example. Okay, I didn't tell you what B was and I didn't tell you what A was. But did you know that B minus A always equals the intersection of A complement and B? Let me demonstrate. Okay, it's always got to be true if it's an identity. Let's do two separate pictures of each, and if the pictures end up being the same, independent of what A and B are, well, I guess it'll have to be true. And if it's always true, it'll be an identity. Okay, let's look at this side. B, take away any portion of A. There's your picture. B, take away any portion of A. Now, in the other picture, let's intersect A complement. Well, where's A complement? That's A complement. And I want to see what portion of that is also in B. Remember? Intersect it with B. And son of a gun, they end up being the same.
Darn tootin'.
So if it's always true, you can use it kind of as a law, as a property, but we call it an identity. Now, what do I care about identities anyway?
Do I can? Yes.
There's one, basically only one, too. One identity that we're going to use basically 3 times this semester. It's called the inclusion-exclusion. Include this, don't include that kind of a thing. Okay, principle. And that is, note what the little n means. The number of members, if you're counting the number of members. The number of members in a union of A and B is always going to equal the number that's in A plus the number that's in B minus the number of members that is in the intersection of A and B.
Holy alphabet.
Once again, the number of elements in A union B will always equal the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. I kind of got a feel for that because I remember we didn't want to count the, when we added 2 things together, we didn't want to count the intersection twice. So if I really wanted to get the number, I add the 2, I'd have to subtract the intersection. Otherwise, I would have counted it twice. Anyway, how are we going to use this? Well, you be ready.
Allow me to demonstrate.
Okay, these are the kind of problems we're going to do. Look at this mug. Typically, a lot of these are survey problems. We've got a survey of 100 students, and it shows a whole lot of facts. It showed that 45 of these students take English, 25 take math, 8 of them take both English and speech, 12 of them take both speech and math, and 6 take both English and math. 2 take all 3. Now, this is just a million surveys that we looked at. I should say 100 surveys, but a bunch of them. Okay, more than you could remember. And 22 take none of these subjects. Okay, so you've got all that information, and you don't want to have to survey these people again for other questions. But you have other questions, and you have to answer them. This is the kind of thing you'd get on a test. Okay, without resurveying these people, which takes a lot of work, I want you to tell me how many take at least one of the subjects. Holy mackerel. How many take math but don't take English or speech? Tough, huh? How many do not take speech of the 100? How many take exactly 2 of these subjects? Any 2. How many? How many take math or English but don't take speech? This looks tough. How many take English and speech but don't take math? These are the kind of questions that someone might ask you, and you don't want to have to resurvey. And this is a relatively small survey. Well, what are we going to use to do this?
Perhaps I could be of some assistance.
We are going to use a Venn diagram. Okay? We'll draw a picture of it, and once we have that picture, we can answer all these questions.
And now, ladies and gentlemen, let's get ready to rumble!
Okay, let's see. And I got a suggestion for you.
And you're going to do it because I said so.
Always don't do it because I said so. Do it because it's going to be the most useful. The most useful number, the one you're going to use the most, is going to be the one in the middle. We want to figure that one. That's the super intersection, if you would. The intersection of all 3 or all 4 or 2 or whatever. So let's see. That's the intersection. That's the person that takes English and math and speech. Wonder what that is. Well, you know what? They told us that. The number, we're looking for numbers now. 2 people took all 3. So that's that. Okay, now what else can I fill in? Well, what I know, and I leave these things kind of boxed so that I know that I've done them already. You want to get all these numbers you can get in there that they give you, because you're going to need them all. 22 take none of the subjects, so I can put a 22 outside kind of all the sets. Okay? Well, let's see. How about this number here? Well, they don't give me exactly that number. That's kind of speech and math, but not English. Wait a minute. 12 take both speech and math. 12 take both speech and math. Now, that 2's involved there, so if I subtract the 2, that must be 10. Get the idea? There's going to be some subtraction involved here also. This one, and I always kind of work my way, as you see, from the inside to the outside. That's somebody who takes speech and English, but not math. Well, they gave me the amount that take both speech and English, but the 2's included in there, isn't it? See why we wanted the 2 first? He's going to be used in just about everything. So if I take the 2 away, I'll know that amount there. Okay? I'm working my way out. Now that's somebody who's taken English and math, but not speech. Well, they told me 6 take both English and math, and once again, that 6 includes those 2 in the middle. So I'll have to subtract the 2, and I can get that number. Okay, what other numbers have I not used here? This one, the rest of the Englishes. Well, they tell me 45 take English. So the whole English set is 45. So if I subtract the 6, and I subtract the 4, and I subtract the 2, I can figure out that portion also. This is the rest of the math people, and they gave me an information for that. They said 25 take math, but that's all the math people. So let's subtract the 10 and the 4 and the other 2, and we'll get that portion of math. We're rolling. We filled in just about every number. Now we have only one other number in this problem. And I want to figure that out, and they don't give me it. But the whole problem should add up to 100. We have a name for that.
I know that, dude.
The universe is 100. So when I have only one space left, I can take all those numbers away from the universe and figure out what's left, because the universe has to add up to 100. And there it is.
Now I want answers, I shall have answers.
Oh, great. Now that you've filled in all the numbers, we can use this picture to answer just about any question you may have. And I have plenty. How many take at least one of these subjects? That's everybody that takes at least one of these subjects. So you can just add up those numbers, or just subtract the 22 from the 100.
Excellent.
And the answer is 78. Get the idea? There's usually 2 ways to do it. How many take math but not English or speech? Well, let's look at the math and the amount that's in math but not in English or speech. Well, that's obvious. That's easy now that you have the picture. How many do not take speech? I want to use the word complement here, don't I? Speech complement. Just add up those numbers. 22, 33, 4, and 9.
Excellent.
Not too shabby. This was tough until we had the picture. How many take exactly 2 of the subjects? Exactly 2. Not 1, not 3, not none. Exactly 2. These are the people that take exactly 2. There's 4 that take exactly math and English but not speech. There's 6 that take English and speech but not math. and there's 10 that take math and speech, but not English. And of course I have to forget the 2 because they take all 3. So I'll add those 3 up, and I can answer the question. I think I had a couple more. How many take math or English, but not speech? That's math and English, and then I subtract. You can see where we use subtraction, isn't it? It's kind of like an A union with B, subtract C, like we had before. And we just got to add those numbers up, and I get
Excellent.
46. One more. How many take English and speech, but don't take math? English and speech, but don't take math. So I have to subtract the 2 out. Okay? And it was an and. So in this case, it was kind of like English intersected with speech, subtract math. And as you can see,
3 words. Fabulous.
the answer is 6. It's not too shabby if you use Venn diagrams.
Okay, see now, what I just heard? Blah, 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 blah.
Okay, well, I guess we'll try another one. Hopefully you can see how they're similar. This is another survey problem, and I want you to notice in this one that sometimes raw data isn't that useful until you start asking questions of the raw data, and this is where Venn diagrams are going to be very useful. Okay, let's see. I got some counting to do. I have a survey of 150 drivers regarding cell phones and tickets, meaning the tickets police give you. 110 drivers said, out of the 150, that they used a cell phone while they were driving. They admitted it. 90 of the drivers said they had received a ticket. There were 120 that either used a cell phone or had gotten a ticket. Now, how does driving relate to use of cell phones, relate to tickets? We really can't see it until we actually draw a picture, I would say. Well, I might want to ask how many both use a cell phone while driving and have gotten a ticket. That's going to be pretty important, and that's not in the raw data. How many don't use a cell phone while driving and have still gotten a ticket? And how many use a cell phone while driving but have not gotten a ticket? That would be of use. All 3 of these questions would be very useful to decide whether you want your maybe your son or daughter to use a cell phone while they drive, or you yourself even.
It's always best to start at the beginning.
Okay, well, we only have 2 sets in this case. The cell phone and the ticket. Of course, the square, the rectangle, is the universe. Now remember, we want to start in the middle. There were 120 that, now this was an either used a cell phone or had gotten a ticket. That's the union, okay? I don't want the union. I always want to start with the intersection. That's the union. Where am I going to write the 120? That's going to be tough. I don't know which number to put where. I can't put the 120 over the whole thing. So this is going to be a little bit more difficult this time. I can't put it there because that's how many people have gotten a ticket. That's 90 said they received a ticket, but there again, I don't know where to put the 90. How to break it up. That's going to be tough. If I had that middle number, I'd know how to break it up. You see why I always want to have the middle number. They told me 110 drivers used a cell phone. That's this portion. But here again, I don't know how to break up the 110. Okay? I need that intersection. I do know that there's a total of 150 drivers. That's the universe.
I know that, dude.
So that's of use, but I still can't figure out how to fill this in. What am I going to do?
And you're going to do it because I said so.
I know I need that intersection, and I can't figure it out, and I can't guess. Remember I told you the identity, the inclusion-exclusion principle, and that's going to help me. Okay? It tells me that the number of members of a union, A union B, is the number that's in A plus the number that's in B minus the number that's in A intersection B. Well, let's see. The union is 120. It's not what I want to know, but that's what it is. The number in A they gave me is 110, right? 110 said they used a cell phone. And they gave me the number for B. That's 90. They didn't give me the intersection, because that's what I want to know. But I can use this principle to find it. And once I find it, I'm in Fat City. Well, let's see. 120 equals 110 plus 90, or 200 minus X. That's got to be 80, doesn't it? Wow. There you go. The inclusion-exclusion principle saved me. Because once I know that's 80,
Now I use my secret weapon.
now we'll start filling in numbers. Well, let's see. What's going to go there? Well, how many actually got a ticket? I know 90 received a ticket. So I'm going to take that 90, subtract the 80, and I put a 10 there. I know how many total received used the cell phone. That's 110. So once again, that 80 is going to come into play. Subtract 80 from the 110, and I know what goes there. And son of a gun, I'm checking there. I can see 120 used either a cell phone or had gotten a ticket. And son of a gun, 30 plus 80 plus 10 does equal 120. I can figure out this area, knowing the universe is 150, by subtracting the 120 from the 150. And now that I've got every area filled in,
Boy, is this great!
I can answer all the questions. Couldn't have done it without the inclusion-exclusion principle, though. So let's go back to our questions. How many people both use a cell phone while driving and have gotten a ticket? 80 people use a cell phone while driving and got a ticket. How many don't use a cell phone while driving and have gotten a ticket? This is the amount of people that don't use a cell phone and they've gotten a ticket. That's very revealing, isn't it? How many use a cell phone while driving but have not gotten a ticket? They've taken the risk with a cell phone but have not gotten a ticket. 30.
I'm running out of compliments here, actually.
And that's very useful information. I hope you figured out that it's probably not the smartest thing to do if you don't want to get a ticket, to be driving around with a cell phone. But hopefully you get the idea how we pulled the data out of this survey using a Venn diagram and the inclusion-exclusion principle. Let's do one more. We're going to send you around a car lot that has 160 new cars. And you're going to have to survey it yourself, finding out how many have various options that your customers want. Okay, so we'll see how this comes into play in business. Okay, and different customers want different mixtures. So, let's see. We've got 160 new cars. 50 have automatic transmission. 80 have tilt steering. 30 have power windows. 42 have automatic transmission and tilt steering. 18 of the automatics have power windows. 15 cars have all three features. 65 have none of the features. Okay? We're going to start asking some other questions. How many cars have both tilt steering and power windows? How many have at least one of the features? And how many have exactly two of the features? Okay? You could answer this question. Well, you couldn't answer it without a picture, that's for sure. But you can answer it easily if you fill in your Venn diagram.
Not because they are easy, but because they are hard.
Let's try this one, because this one is especially tough, and I think it'll demonstrate some concepts for you. Okay, let's see.
And you're going to do it because I said so.
Remember why we want to start in the middle, because we're going to use that to subtract from various numbers and figure out other numbers. So don't do it because I said so. Do it because it's really the only way to do it. Start in the middle. And that's going to be the cars, hopefully they'll give you, that are automatics and have tilt steering and have power windows. And they told us that. So there it is. That's Fat City. Put that baby in there. Okay? Now let's see. What else can we derive? Oh, the 65. I like the ones that have everything and the ones that have none. That'll be of great use. Now this is a section that is automatics that have power windows but don't have tilt steering. 18 of the automatics have power windows. But remember, 18 of the automatics have power windows, but that includes the one that have tilt steering. So let's subtract the 15, and you get kind of the idea. Okay, we get the 3. Okay, now this one, looking at the picture, is going to be automatics that have tilt steering, but don't have power windows. Well, we know 42 of the automatics have tilt steering. 42 of them, but they didn't say anything about power windows. So let's subtract the 15, and we'll get that number. Now we're rocking. Okay, do we know how many automatics total we have? We do. So we have 50 automatics. So all those numbers inside the red should add up to 50. So let me subtract the 27, the 15, and the 3 from 50, and we'll get that one, the automatics that don't have the other two. Okay, I've used a lot of this. Now, let's see.
I know that, dude.
Our universe is 160. How's that going to help me? I don't know. I have 80 that have tilt steering total, all 80. Now this is going to be a problem because that's tilt steering and there's 2 parts there. How do I separate the 80? 30 have power windows. Here again, I have to break it up. And I don't know how to break up the 30. Whenever you don't know how to break up something, remember what we did?
Oh, I can't take it anymore.
To use the inclusion-exclusion principle, I would have to have the union of 2 things. I don't know the union of tilt steering and power windows. And I don't know the union of anything, really. So I'm not going to be able to use that. I'm going to do, this is a little tricky one. I'm going to have to come up with 3 numbers here, aren't I? So I'm kind of going back to maybe a month ago when we covered systems. And if I want 3 variables, I'm going to have to come up with 3 equations. Well, let's see. I know how many tilt steerings I have. There's 80. So I'm thinking x plus y plus 27 plus 15 has got to be 80. There's one equation. Okay? In other words, x plus y plus 42 is 80. Let me subtract and simplify this equation. And I've got one equation. X plus y is 38. Okay. Well, I need a couple more equations.
Insufficient data.
What about, I know I have a 30 total for power windows. So, couldn't I say the z plus the y plus the 3 plus the 15 is the area in the green? That's got to equal 30. Z plus y plus 18 is 30. Let me simplify that. Subtract 18. And I'll get z plus y is 12. There's a good, useful equation. But I need one more equation because I have 3 variables.
Are you pondering what I'm pondering?
Let's involve 160. If I subtract everything except the x, y, and z, I should get, or if I add up everything, I should get 160. Okay, and I know all the other numbers. So x plus y plus z, putting all those numbers together, plus 115 has got to equal my universe. Let's subtract 115 from both sides. And x plus y plus z will have to be 45. Now I have 3 equations. Okay, and I can solve those 3 equations. We could use a matrix, but it looks like it's going to be pretty easy to use substitution. So let's do that. I know what y plus z is. So instead, in the first equation, instead of y plus z, I'm going to put what y plus z is equal to. And what is y plus z equal to? 12. Let me put 12. Well, now I have an equation with only one letter. So x must be 33. I'm rolling. This is a tough one. Now I know what x is.
Certainly.
I can put it there and figure out what y is. 33 plus y is 38. So y must be 5. Now we're rolling. And once I know what y is, I can figure out what z is by subtracting all those other numbers from the total number in Power Windows.
Yes!
And I have all my numbers. Okay, I don't think I'd give you something like that on a test, but I wanted to impress you to show you that you could use systems to do it. Let's get to our questions now. How many have both tilt steering and power windows? There it is. It's right in front of your face once you put in the numbers. 20. How many have at least one of the features? Meaning at least one means I have 1 or 2 or 3. In other words, not none. That's the union of the 3. So basically 160, take away the 65. And I get 95 have at least one feature. How many have exactly 2 features? Not 3, not 1, 2. It's going to be those. Take away the 15. So just add up those 3 numbers. 27, 3, and 5.
That's all I can say. Sheer, unadulterated brilliance.
Good old Venn diagrams.
Nerd alert.
Uh-oh. It's time for you to practice. Now remember, start in the middle. And if you have a union, you need to break it up. Use the inclusion-exclusion principle. Okay? Dig in.